All right, our last section with division of decimals. And now, eventually here, I'm going to start with a little something I like to do to make sense of what we're going to do today. But we are going to now have a decimal divided by a decimal. So both of them will have decimal places in them. I want to show you something that I think helps make sense of how we can take care of having both of them be decimals and not make them be decimals. Let's see what I'm saying. So what is 4 divided by 2? Hopefully in your mind you're saying 2. What is 40 divided by 20? So how many 20s are in 40? Still 2. What is 400 divided by 200? How many 200s are in 400? Well, there's 2. So notice that if I times both numbers by 10, my answer doesn't change. If I times both answers by 10, my answer doesn't change. Here I have 40.0 divided by 20.0, so it's actually the same problem as up here. I just added a 0.0, which has not changed the value. My answer is still 2. Oh, I forgot my question mark. So now what if I divide both numbers by 10? So I'm going to divide 40 by 10 and get 4, divide 20 by 10 and get 2. So what's 4 divided by 2? Still 2. I'm going to divide by 10 again, both numbers. So how many 0.2s are in 0.4? Well, it's 2. So if I'm changing my numbers the same, I am not getting a new answer. So let's take that into consideration when we go here. The problem I have is 1.71 divided by 0.9. So they both have decimals. Same thing, the second number goes outside, the first number goes under. But before, we could just say, oh, just store your decimal up top. But I don't know about you, thinking about how many 0.9s are in something is really difficult for my mind. So I would rather deal with whole numbers. So if I multiply this number by 10 and move my decimal, I also then have to multiply this number by 10. That's what I was showing you on the page before. If I multiply both numbers by 10, I'm not changing my answer at all. So I moved my decimal 1 on the outside, so I had to move it 1 on the inside. That's multiplying both numbers by 10. And then I moved my decimal up top. If you want to, you could rewrite the problem if it's still too much to look at. So now I have 9, and my decimal's here. And I have 17.1 because I multiplied both by 10. If that makes it easier for you to look at, you could rewrite it. So how many 9s in 1? Well, there aren't any 9s in 1. 9s in 17. Oh, I'm just shy of getting 2, so I can only get 1 out. Oops. That's why we work in pencils. I can only get 1 9 into 17, and if I subtract 9, 17 minus 9 is 8. I pulled enough out because 9 doesn't go into 8, so I have to bring the next number down. 9 goes into 81. This is where you could use your multiplication table, but 9 goes into 81 9 times. So subtract the 81 because 9 times 9 is 81. Nothing's left over. I get an answer of 1.9. I don't have to change it at all. Since I multiplied both numbers by 10, my decimal's in the right place. I did not change my answer because I multiplied both of them. So we're making our problems match what we were doing before. A whole number out front makes it a lot easier for us to do our division. The few practice problems here. So it'd be a great idea to try and then see my work. I'm going to go through a few of these. They're going to get a little bit more difficult as we go. But I have 0.6 and 2.64. I don't like having the 0.6 out, so I'm going to multiply by 10, bring my decimal up. If I want to rewrite that, I can, just so that it looks cleaner on my end. So 6 does not go into 2, but it goes into 26 4 times. 6 times 4 is 24. Subtract 2, bring down the 4. 6 goes into 24 4 times, because 6 times 4 is 24. So we get an answer of 4.4. So I multiplied both by 10, doesn't change my answer as my value. Now we got lots of zeros, so this is where it gets fun. 0.002 goes on the outside. 0.123, 28 goes on the inside. I'm not just multiplying by 10 now, I'm multiplying by 10, 100, 1,000. So if I moved it 3 to get this to be a whole number out front, I'm going to go 1, 2, 3 inside. Our goal when we do this is to get our outside number to be a whole number. So 2 is outside now, and I moved this to be 0.28. And technically I could have got rid of those zeros, but so 2 doesn't go into any of these, but 2 goes into 2 once, and it goes into 8 4 times. So I got an answer of 0.14. And you can put a 0 up front if you want. That doesn't change it. So you have to get this second number to be a whole number, but however many times you had to multiply it by 10, you have to do the exact same to the inside. One more practice one here. We have 0.42, 1.47. To get 0.42 to be 42, I have to multiply it by 10 and by 10 again. So I do the same thing on the inside. And then this one ends up, both of them are whole numbers. 42, 147. So 42 does not go into 1 or 14. I have to figure out how many in 47. 42 is not on my multiplication table, so this is where I have to do some side math to solve this one. So 42, if I count by 40s, 40, 80, 120. I'm going to try timesing it by 3 to start and see if I need to add on another one. So 3 times 2 is 6. 3 times 4 is 12. So I'm at 126. Can I get one more 42 on there? Nope, too many. So we're going to have to stick with this. 3 minus 126. I only have 21 left over, so that's good. There's nothing else for me to pull down. This is where sometimes we have to think about where that decimal was. We can add zeros, and we can keep adding them if we need to. So if I count by 40s, 40, 80, 120, 160, I'm going to try 5 of them. 42 times 5, 10, 21. Ah, look at that. It works out perfect. So my answer here is 3.5. A little bit trickier when we have those large numbers without the multiplication table. All right, I am going to pause my video and get my work all on here, and I'm asking you to pause as well because in a minute here, all the answers are going to show up. So make sure that you hit pause. I want you to practice these. So think back to those problems I did. If you need to rewind the video to see how we solved them, go for it and do it that way too. All right, so lots of work here that you can see through. This first one, you're taking 17 into that 544 is what it ends up becoming because you get to multiply both by 10 and have whole numbers. 17's on your multiplication table, so hopefully that one went pretty well for you. B got tricky. If you got it right, give yourself a huge pat on the back. That's a tough one because you're taking 36 into this very large number. You had to move the decimal place twice on both numbers. And I had to do a lot of side math to figure out how many 36s I could fit into those big values. So if you got it all right, awesome. And then this last one looks intimidating, but once you start to multiply by 10 3 times and by 10 3 times, we have 7 into 6.3, and 7 goes into 63 9 times. So you just have that one value on the answer there at 0.9. All right, we are almost done with the practice here. I'm going to let you do this at your own. If you're feeling like, yep, I'm getting this, you can move on to the homework that's posted. Or if you would like to see the work of a few more, I have more practice here. I will solve through these. And then if you're feeling like, yep, I'm ready, let's go on to the homework, that's fine. If you want to watch me solve some more, pausing, trying yourself, I think that would be a great idea as well. So 0.4 into 52. I want a whole number out front. Uh-oh, my 52 doesn't have a decimal, so I actually have to add on a 0 before I can do that because I had to move it on both numbers, otherwise I'm changing it. 4 goes into 5 once, 4 goes into 12 3 times, and I'm done. But there's a gap before my decimal here, so I do need to fill with a 0. This equals 130. 0.18 into 0.009. 1, 2, 1, 2. So I'm looking at 18 into 9, and 18 doesn't go into 9. So this is where you might have to add zeros. So it doesn't go into 9, but it would go into 9D. And so if we use, I can get 18 into 95 times. I use the multiplication table for a quick reference. You could do 18 times 5 over here and get 90 as well. And so it actually goes in nicely. So be careful with problems like that where you have to add on zeros. 0.07 into 11.2, 1, 2, 1, 2. And so 7 doesn't go into 1, but it goes into 11 one time. And 7 minus, so we're countable 4. 7 goes into 42 6 times. And I'm done, but careful, my decimal landed way back here, so I do need to fill with a 0. So those of you who stuck around, that's a good page to see because it's showing us how to handle situations where we don't have enough and we needed to add more zeros. So hopefully the homework goes well and you're asking questions of me if you're not making sense of what we're trying to solve.